In this video, we are going to solve some exercises from chapter 12. We will start with exercise 1. First, in the exercises 1 to 5, the line D has a system OI such that the norm of I is equal to 1. Exercise 1, locate the points ABC such that OA is equal to 2i, OB equals to 1.5i, and OC equal to minus 3.5i. So first we draw the line D. And I will specify here O, the origin. Okay, so I will let this be O. And I, so we start by specifying O and I. So I will be this vector from here to here. So this is vector I. It means this is 1, this point is 2, this is 3, and so on. Okay, I will not write all of them. And so on. Now the question is to plot point A. A is at 2. So this is A. Point B. OB is 1.5i, which means B is here in the middle at 1.5. Point C, which is minus 3.5. So this is minus 3, therefore this is C, minus 3.5. So this is an easy question. Find the abscissas A, B, C. So since we located the vectors OA, OB, OC as such, so this is, we have to draw them in vector form. So this is OA, let's say this is OB as a vector, and this is OC. Okay, then find the abscissas of A, B, and C. This will be very easy. A is simply 2, B has abscissa 1.5, and C has abscissa minus 3.5. Okay, so when we write this A2, it means the abscissa of A is 2, which means XA is equal to 2, XB is equal to 1.5, and XC is equal to minus 3.5. Exercise 2, locate the points A, B, C such that so first we have BO equals to minus 3. So first let's draw the point O and vector I. Okay, BO is minus 3. So to draw point B, I will write OB first. So what's OB? OB is equal to 3i. Okay, so it means the abscissa of B is 3, which we will find in the second part. So OB is 3, so 1 unit, 2 units, 3 units. So this is point B. And AB is 2i. So from A to B, I will have to move 2 units to the right. So A has to be here. Okay, so this is A here. Okay, so this is A, this is B, and finally AC should be minus 4.5i. So to go from A to C, we have to move minus 4.5 units to the left because it has to be opposite to I. So 1, 2, 3, 4.5. So it will be here. So this is point C. Okay, so starting from A, we move 4.5 units backwards. 1, 2, 3, 4. And 0.5. So let's number the axes. So this is minus 1, minus 2, minus 3. This will help us find the coordinates from the graph, from the number line easily. Minus 4, this is of course 1, 2, and 3. And now the second question, determine the abscissas of points A, B, and C. So clearly here, XA is 1, XB is 3, and xc is minus 3.5. This means that I can write a of 1, b 3, and c minus 3.5. Now, part C, find BC, CA, BC, and AC. So BC, an algebraic measure. So we have to pay attention that BC, algebraic measure of BC, is the same as length of BC with a plus or a minus depending on the sense of vector BC compared to I. So here, to go from B to C, you can simply count the units. The easiest way here is to count the units. So how many units do we move from B to C? So we have 1, 2, 3, 4, 5, 6.5. So it's 6.5. Does vector BC have the same sense as I or opposite? BC moves like this in this sense, while I is in this sense. So it means BC and I have opposite senses. So we have to add a minus here. Okay, similarly for CA. So CA, algebraic measure of CA. So to go from C to A, we move 0.5 unit, 1, 2, 3, 4. So 4.5 units. Is it in the positive sense or negative sense compared to I? So CA, vector CA, has the same sense as I. This means that it's plus. Now for BC, BC of course has to be positive. So it's just 6.5. You can put absolute value of course of this and write directly, 6.5, or you can simply write 6.5. CA is always positive, so you take the absolute value of the algebraic measure, it gives you 4.5. Exercise 3, locate on D the points E, F, and K of the following abscissas. So I will put here O, for example. This is I, okay, and F is here, K, so 2, 3, 4, and 5, so this is K, and we have at minus 1.5, we have E, so this is minus 1, this is minus 2, point E will be here in the middle. So I'll name the points. This is E, this is F, and this is K. Calculate EF in terms of I. So because here we have the number line, so it's easy to find EF directly from the number line. So to move from E to F, how many units do we move? We move half unit, 1, 2, so 2.5 units. So to go from E to F, you have 2.5 units in the same sense as I. So it's 2.5 I because they have the same sense. So it's not minus 2.5. Now calculate FE, and FE, algebraic measure, and length or distance. FE, algebraic measure of FE. So notice that FE is 2.5 units. Now to determine whether it's plus or minus, you have to look at the sense of vector FE. Notice to go from F to E, you move in this sense, while I is to the right. So I and FE have opposite senses, so it has to be minus. However, FE without algebraic measure is simply the distance between the 2 points, so it's positive, so it's 2.5. Similarly, we want to find FK. So what's vector Fk in terms of I? We count the units and determine whether it's a plus or a minus. So Fk, so to move from F to K, we move 1, 2, 3, 4 units. So it's 4I, not minus 4I, because Fk vector and I vector have the same sense. Now, similarly, we find Kf, algebraic measure. The algebraic measure of Kf, notice Kf has the opposite sense of I, so it's minus 4, and Kf without algebraic measure is simply the distance, it has to be positive, so it's 4. Exercise 4, locate on D the points M, N, and P and Q as such. So I will let O be here, I need M here, so at 1, so this is I. Okay, so this is point M, point n is 2.5, so this is 2, this is 2.5, and p is minus 3.5, so minus 1, minus 2, minus 3, minus 4, so this is minus 3.5 p. Now part B, find the abscissa of the point G so that Gm plus Gn plus Gp plus Gq is equal to the 0 vector. To find the abscissa of point G, we need to find OG in terms of I. So I want to write OG as something times I. And this question mark here that we are going to find will be the abscissa of point G. To do this, we can start with this equation with vectors and insert letter O here, 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 and here. Okay, so by Chase's rule, we can insert O in the 3 places in order to get a G with O only, and nothing else, because G is our unknown point. Okay, so if I insert the G, O here, we get the following equation, this one, and then I combine the GOs together, so I have GO, so 4GO, so we got here 4GO plus the rest, OM, ON, OP, OQ, and then I took the 4GO to the other side. So if I take this to the other side, I will get minus 4GO, which is the same as 4OG. So I wrote it here, 4OG equal to these. Then divide by 4, so you get 1 over 4 OM plus ON plus OP plus OQ. Then I substituted OM, ON, OP, OQ in terms of I. So OM is I, ON is 2.5I, OP is minus 3.5I, OQ is 6I, and I did the calculations to get 3 over 2I. So G is 3 over 2. Now, another way of doing this would be the following. I could have, in this step, instead of working with vectors, I could have directly changed to coordinates, abscissa. So here, for example, I could have written xm minus xg plus xn minus xg plus xp minus xg plus xq minus xg is equal to x of 0, which is 0. And then I substitute all the numbers and solve to get the value of xg. Of course, you get the same answer. Now let's move to exercise 5. In exercise 5, the first part is very easy. It's just plotting the points. The second part, determine the abscissa of points m and n defined as such. So similarly, as we did before, to find the abscissa of m, it means I want to find OM in terms of I. So I can insert here letter O, and then as we did before, we solve to get OM. Okay, so you can do the work by yourself. It's very easy. You solve to get OM. We got here OM equals 1 over 4 into minus OA plus 4OB plus 3 OC. So here we have two options. Either I substitute here in terms of I, so I write this as minus 3I plus 4 into minus 3.5I plus 3 into minus 0.5I and then simplify, or I can convert this from vectors to abscissas, so to x. Since the first letter here is O, so the x of this vector OM is the same as xm, and similarly here this is the same as xa because x of vector OA is the same as x of A because O is the origin. Similarly, this is x of B and this is x of C. I substitute the numbers and get the answer. As I said before, I could have not skipped this step, okay? So you could have done the following. From this step, I can say xa minus xm minus 4 into xb minus xm is equal to 3 into xc minus xm. And then substitute the numbers, everything, xa, xb, xc. You remain with xm, you solve for xm, and you get the answer. So this is another way. You can choose whichever way you want. Now, I applied this method to this one to show you various methods. Now here we have NA over NB in algebraic measures equal to minus 2. So I can replace NA. You know that NA is equal to XA minus XN. And NB is equal to XB minus XN without absolute value, because here the sign is important. It's important if, to have a sign positive if the vector NA has the same sign as I, and negative if it has the opposite sign. So you just write XA minus XN over XB minus XN equals to minus 2, as I did here. Then I substituted the values of XA and XB and cross multiply. So you get XA minus XN equal minus 2 into XB minus XN. After you substitute the values of XA and XB, which are here 3 and 7, 3 and minus 3.5. You do the calculations, expand and isolate xn on one side of the equation, and you get that xn is equal to minus 4 over 3.